In this video we're going to look at exponents and equations that involve exponents and problems that we can get with exponents. So let's look at some of the rules governing exponents. The first thing, if I multiply two terms together with the same base, we add the exponents. If we divide, we subtract. If we've got a term with an exponent raised to another exponent, then we multiply those powers. That if we move a term from the denominator to be in a numerator or the other way round, the sign of the exponent changes, and if we want the nth root, we can write that as an exponent where it's the reciprocal of n. Okay, so this slide is actually quite an important one when we're trying to solve the sort of problems we're going to get on a Schol paper. So let's say that a is greater than 0 and we're saying y equals a to the n. Now, here we go, once positive, always positive. So if a is positive, no matter what value we give n, positive, negative, decimal or integer, the value of y will always be positive as well. And let's just note, if we had a to the minus n, so effectively making this negative, because it's 1 over a to the n, well obviously this is positive. We've already shown that this is positive, so the answer is going to be positive. So let me stress that again. If we have something in this form and the base is positive, then this value here will always be positive. Okay, so let's look at one of the patterns that we should be going for, and this is powers in powers. And here's an example. Let's say we had 16, we could write that as 2 to the power of 4, and we do that just by noting that 16 can be written as 2 to the power, and this one can also be written in the form 4 to the power of 2, and the change we would make would depend on the question we've got. So let's look at this question here. Solve this problem here, and the thing that we notice here, that we've got this base of 2, that certainly can't be simplified, but here we've got this base of 4, and because we know 4 can be written as 2 to the power of 2, this can become 2 squared to the x, or 2 to the x squared, just switching those around. And here 2x, 2 to the power of x plus 1, well that's 2 to the x times 2, writing that the other way round, we get this expression here. And this is really quite an important thing that we have to do. So if we let y equal 2 to the x, so we can change this for y and this for y, we get this quadratic. And that gives us these two possible values for y. Remember what we said in the last slide? That, you know, that if this, because this is positive, y is always positive. So that gives us then, in this case, that this one can't be right, so y must equal 4, so that means x must equal 2. Okay, so now we're going to look at one more pattern, and that is when we've got this one here, because notice this would be a to the minus n here, and this is going to give us another quadratic, because what we're going to do in this case is we're going to get rid of that denominator by multiplying both sides by a to the n. And here we get a to the n squared, here we get a to the n. If we move that over to here, that's our general form of a quadratic. Let's look at this problem here. So I've got that same pattern going on again. So I'm going to multiply both sides by this denominator, and I get this expression here. Well, if I let y squared, and you know, in a lot of situations it would just be a y that we could go for, but I want to deal with this square root. So if I let y squared equals 3 to the x, then this expression, well, this becomes y squared. Here's our negative 18, and this will become 3y, and obviously we bring it to the other side, we get this expression here, and that gives us y equals 6, or y equals negative 3. Same thing happens. 3 is positive, so 3 to the x is positive, so y squared is positive, and we've got y is positive as well. So that's going to give us 3 to the x equals 36, so that is going to give us that x equals the log of 36 over the log of 3. In the description below you can find a link to a worksheet that has questions that you can try on your own. I hope you found this video helpful. Stay in field with Winfield.